Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.8 Notes, Day 2. Today we're talking about special cases and compound inequalities with OR. Okay, our learning target today is solving special compound inequalities. All right, let's take a look at example number 1. So it says 3x minus is less than or equal to negative 18. So to solve that, we need to divide both sides by 3. And we get x is less than or equal to negative 6. So that's our first one. Now our next one is negative 4 is less than or equal to negative 2x. So the first thing we need to do is to divide by negative 2. And we get 2, we have x, and what did I just divide by? Yeah, if you divide by negative, you have to flip the sign. Use a different color for that, okay? And now the next thing is we have to rewrite that because we want the variable first. So x, it's pointing at the x, the inequality is. We got x is less than or equal to negative, or to 2. So as we graph this, I'm going to start with negative 6. Okay, so we're starting with that negative 6. It's open. And we shade to the left. Okay? But now our next one is at 2. And that's closed. And we shade everything to the left. So see how that negative 6 got filled in? Okay, so now we have to write this in interval notation. Our graph starts at negative infinity, it's open, and then it stops at 2, and it is closed at 2. Okay? All right, so the first thing you see is the open circle is at 2. The 6 is an open circle, but since the other inequality filled it in, so now the answer is included in our final answer. All right, let's look at example number 2. So example number 2, we need to solve for k. Going to add 5 to both sides, and we get negative 2 plus 5 is 3 is greater than k. We want the variable first, so we're going to rewrite this. The inequality is pointing at the k, so I'm going to make sure it stays pointing at the k. All right, now to the other side. We're going to subtract 9 to both sides, and we get 4k is greater than negative 3. I'm going to divide both sides by 4, and we get k is greater than negative 3/4. Okay. So now when we graph this, we've got 3. Oh, I'm sorry. 3 should be over here. At 3, it's open, and I shade everything to the left. But my other number is negative 3/4. That's open, and I shade everything to the right. And now what's our graph? Well, when we look at our graph, it starts at negative infinity, but then it ends at positive infinity, which means any answer could work. Okay, it's special case. All right, example number 2. So this part right here, I'm sorry, this part should have gone with that right there. So what is the total area that's being shaded? It's the whole thing. The interval notation would be negative infinity to positive infinity, or all real numbers work. All right. So for example number 3, we're subtracting 2 to both sides, and we get x is greater than 6, or we have to add 6 to both sides. We get 2 is less than x, but then we have to rewrite that. So x is greater than 2. Okay? So we always want to put these in order from least to greatest. So there's our 2 and there's our 6. At 6 it's open and we're shading to the right. At 2 it's open and we're shading to the right. So now when we plug that in and go into interval notation, it's open at 2 and it goes all the way to positive infinity. Okay? All right. Example number 4. First thing we have to do is add 8 to both sides. We get 9m is less than or equal to 0. Divide both of those by 9, and 0 divided by 9, we get m is less than or equal to 0. Okay, on the right side, we have to subtract 7 to both sides, and we get -5 is less than or equal to m. We need to rewrite it, so we have m and -5, and it's pointing at the 5, so I'm going to make sure it stays pointing at the 5. So I got m is less than or equal to 0, or m is greater than or equal to -5. So there's -5, there's 0. Oh, we should rewrite this. So m is greater than or equal to -5, or m is less than or equal to 0, because we want them in order from the lowest to the highest. All right, so at -5, I am closed, and I'm shading everything that's greater. At 0, I am also closed, but I want to shade everything to the left. Okay, so once again, they're talking about everything. So that's a graph that's the set and interval notation is -infinity to positive infinity. Okay. All right, guys, that's it for Algebra 2, Chapter 3.8 Notes, Part 2. If you have any questions, please come see Ms. Carranza or myself. Otherwise, thanks for watching.